So historically, here's where we're at. Newton has come up with big G, M1, M2 over d squared. Now we can explain, and this is going to be important, that the gravitational force between Mercury and the Sun changes as Mercury goes around its orbit. Okay? So this is one big idea. Okay? This allows us to actually, if we knew the mass of Mercury, and we knew the mass of the Sun, and we actually knew the distance in meters, we could actually calculate that force and go, okay, this is what the actual value of the force is. Okay? So, if you look at as Mercury goes around in its orbit, this would be F equals big G, mass of Mercury, mass of the Sun, over distance squared. So as Mercury goes around in its orbit, what happens to the value of big G? Stays the same. What about the mass of Mercury? Stays the same. Mass of the Sun stays the same. Okay? So the top number isn't going to change. Okay? Because that's based upon a gravitational constant and the mass of the planet and the mass of our star. Fixed value on the top. Does distance change as Mercury goes around in its orbit? Yes. So that's what we just proved. So when Mercury is closest, what happens to the gravitational force? It increases because you're dividing by a smaller number. Okay? When Mercury is at its furthest point, you're dividing by a bigger number, force goes down. So the gravitational force between Mercury and the Sun is a function of the orbital radius. So orbital radius gets bigger, force gets smaller. So that's one side of this thought process that you need to understand. Now, they also knew Newton's views on circular motion. So this is where Mercury deals and acts like a rubber stopper going around over your head. But instead of that rubber stopper going in a perfectly circular path, imagine that the path of that rubber stop, the distance of that rubber stopper is continuously changing. It goes from a bigger radius out to a smaller one, and then it comes back to a smaller one. So instead of having a constant radius, imagine that you're swinging this thing around and that radius is continuously changing. Ah, cool, right? So that amplifies things. Radius is changing. So if you look at the idea that centripetal force equaling mv squared over r, okay? Basic idea of centripetal force, okay? mv squared over r. This is why you have to learn centripetal force before you learn gravitational field. So is that mass going to be the mass of Mercury, or is that going to be the mass of the Sun?
Mercury.
Mercury, why?
Because centripetal force only acts on the object that's...
Yeah, if I were to calculate the centripetal force acting on this rubber stopper, I'm not going to use my mass, okay? I'm not the one going around on the end of the circle, okay? Same thing as this. The Sun isn't going around Mercury. Mercury is going around the Sun. So that would be the mass of Mercury. Now, this is where Newton meets Kepler. We're going to merge these two ideas together. So, if you look at two extremes, so you all just said that when Mercury is closest to its orbit, what do you know about its velocity?
Increases
Biggest velocity. So at this point, Mercury has its biggest velocity, okay? Floom, hauling around the Sun, small. But what's happening to the radius?
Decreases.
This is when you have your smallest radius. Okay? So look at this. So if you look at centripetal force equaling the mass of Mercury times the velocity. But what do you know about the velocity? Big number, small number?
Bigger. Big.
It's a big number. Not only is it a big number, it's also squared. Okay? So the mass of Mercury multiplied by a big velocity that is squared. But then you're going to divide by the radius. Then you're going to divide by a smaller radius. So what's going to happen to the centripetal force needed Mercury in orbit when it's getting closest to the sun? Big, small? Big. So when Mercury is closest, that requires more centripetal force. Cool. So I've got to have, at that point, a big centripetal force because I have a mass multiplied by a big velocity that's squared, then I'm going to divide by a small radius. So something has to provide that force. So either Mercury is rolling on a dirt track and friction is doing it, and there's a little steering wheel on Mercury going, okay? There's a string tied between Mercury and the sun. That's even weirder. I think it might burn up. Or there's gravity. Let's go with gravity. But at this point they go, this is why these two things go hand in hand. Because when Mercury is closest in its orbit, what happens to the amount of gravitational force? Big or small?
Big.
Big. So Mercury says, man, I got a haul around the sun. Small radius will be going fast. Gravity goes, I got you. Okay? I can make this happen. Because gravity is going, I'm going to be strongest when it's closest. I'm going to be strongest when you need the most centripetal force. It's cool. It works. So it couldn't work the opposite way. You could not have this orbit if the gravitational force became smaller when it was closer. It was like, hey, I need to go really fast, and gravity says, nah, I'm tapped out. As a matter of fact, I'm just tired, okay? You're on your own. Mercury goes, I'm screwed, can't make the orbit. So this is why these two things have to go hand in hand. Now, when you go out here on the far part of the orbit, what happens to the velocity?
Smaller decreases.
It becomes smaller. That's kind of cool. So now, at that point, the centripetal force is going to be still the same mass of Mercury, but what happens to the velocity? It gets smaller.
Big R though.
Big R. So you don't need as much centripetal force. Gravity says, I'll chill with you. Okay, I can chill out too. Because gravity's going, I won't be as strong. Because I'm dividing by a bigger radius. Okay? And at that point, everybody goes, this is why it works. Because of that change in gravitational field. Now, if Mercury, and it didn't, but if Mercury traveled in a circular path, would you ever need the centripetal force to change?
No.
No, because everything would stay the same. Guess what else wouldn't change? Gravitational force. Because it would always be traveling at the same orbital radius. Okay? One of the most important things you have to understand is that relationship right there. Okay? Between centripetal force, gravitational force, velocity, and radius. Closer, need more centripetal force. Gravity says, I got you. I'm going to get stronger. Further out, centripetal force says, I'm going to chill out. I'm going to be going slow, bigger radius. Okay? Going to hit the hookah lounge, kind of chill out for a little bit. I need my space between the sun. Gravity goes, hey, I'm with you too. We'll both chill out at the same time. Okay? So when they're both chill, they're both chill. When they both need intensity, they're going to go side by side. Makes sense. Okay. Now, when you get to question number 4, what you're going to do on question number 4 is you are going to calculate the gravitational force between the Mercury and the sun and knowing that radius. So on number 4, you're going to use F equals big G, mass of Mercury, which I gave you, mass of the sun, which I gave you, and the distance between them. Okay? Now, I was not a jerk on this deal. I gave you the radius as meters. I didn't give it in astronomical units. It's 10 to the 10th. Okay? Gave you the mass of Mercury. All you have to do is calculate this number. It's going to be a big number. Okay? Because of the fact that, hey, these are two massive objects that have a strong gravitational force between them. Now, when you get to number 5, you're going to use centripetal force equals mass 4 pi squared r over t squared. Now, what does the centripetal force have to be in? What units? Newtons, which are kilograms meters per second squared. So what does the orbital period have to be in? When you take the 88 days and you convert them into seconds, do not round that number, okay? When you convert anything into seconds, and we're going to do that a lot, okay? 1 day is 24 hours, so it's 3,600 seconds in an hour. When you do this conversion into seconds, don't round that number, okay? Because that's exactly how many seconds there are in 88 days, okay? Don't round that number. So if you do this right, you should be able to very easily see the relationship between these two values. So when you get all of this done, okay, here's what I want, here's how I want this handed in. I want blue sheet, then graph, and then the sheet that has the data on it, and I should be able to see the boxed in, shaded in areas on that data which indicate the 10-day periods that you chose. So, blue sheet, circle graph, data, in that order, okay? So, when you get done with that, get that handed in.
I have to think so. That's just you and Sammy in a tree.
Both of your answers on that last page of this calculations of force should be big numbers.
Just scribble on it. Not the arrow.
It's this one, so am I
Just
correcting these?
Yes, you're gonna plot all of those
so you
points
can't.
on this graph.
Okay.
Yeah, but it makes
And
it
then
harder
is
to
this whole
tell.
thing pretty much based?
Yes, the whole thing is based on that.
I believe in Emma. Emma believes in me. Hey, what'd you get on number 4?
Soccer.
Just said it.
Good luck.
Just said it.
Who do you guys play? Are they any good?
Yeah, because he said, and get it turned in. Yeah. Oh, you know what?
Well, it's either distance or radius, which is, this case would be the same thing. It's never diameter.
They're the same thing.
Yeah, so,
I use this.
so if I swirl this around over my head, yeah. If I swirl this around over my head, the radius is the distance from me to there.
Okay, how do you like the radius is 5,000
No. That distance I do is the distance from the sun to Mercury. That distance.
Blue paper graph. I have to go.
Are they supposed to be close to the sun?
Yes,
Slightly different.
yeah. That's just rounding.
Is my relative force here back?
It cannot be less than 1.
Wait, we didn't get the same.
Because the weakest force is at its furthest distance.
You just rounded. Yeah, we did. I thought
So it has
I'm
to be
blind.
somewhere between 1 and 2.3.
Never mind. Nothing. Never mind. Is it wrong? No.
Also, is this due
I was right.
Tomorrow at least.
I'm sorry. I got 1.27 times 10 to the 20.
You know, earlier she
No,
looked up.
what does this say?
D2 constant.
That's D2.467.
Yeah, no, okay, I helped them.
Oh, earlier you drew an ellipse up here and you clearly said it was an ellipse like 10 million times. Then she looked up at it and said circle. She did.
No, what made me laugh was when Natalie went, "Oh, I like circles."
No. Is this correct? Here's the last question.
1.27 times 10 to the second.
Beautiful.
You were so mean.
I am understanding something. God.
I could just get visit Toby, actually.
Not good.
So I did that, and I put that down there because it was the buffer. I did that. Where did you get the
I don't think that's
mask and stuff? That's not a mask.
You said you appreciate
Oh, I just can't read your
Does this work or?
Does this number
I'm
right
telling you, look reasonable for
Oh, God, no.
We did this.
It's not even close.
Or a bitter.
Well, isn't it already everything?
Can I give you a
No,
hint?
but like even every.
That's over like a bar square.
Oh, ours, I just divide by R squared, that's fine, yeah. I just divide by R.
Yeah, I can.
What was this? Detormon? Detormon?
Okay, so is Mercury over
Wait, so 88
does that
times
require something
54
like
times
that?
0.00,
Which you found
right?
here, okay? That's how much force it takes. So there's either a string that we tie between Mercury and the Sun. It's driving around on a track and there's friction, or there's gravity.
So for number 5, where did you get
So
the
the
math?
gravitational force that's here is provided
Still not have
the
it?
amount of centripetal force. Yes, if these numbers were different, like if you.
I wish Kayla was here because she would be on my
the
side.
centripetal force to be like.
Hey, Kayla can be mean sometimes too.
I know, that's why I love her. That's why we're best friends. Because she can be mean and nice, and that's what I like in her.
See there.
Bro, you're such a hypocrite. You hear her, Emma? She said, what I like about my friends is that they're mean and nice, and then side
So-
eye me.
It really doesn't have any direct What's more important is that as Mercury goes around in its orbit,
What? It's your mom.
because it has to, because it has to be a certain unit, which means something has to provide
That's why
that.
we need to be on such good.
Yeah. So,
Yeah.
since
No, the girl who like dresses up
which
around
this
the
is teaching about relationship,
the one dinner is a cool relationship
those are good things.
with that one.
So, the reason that these numbers is because the gravity provides just the right amount of centripetal force.
I was annoyed.
Okay? So like if this had been, let's say you worried about. So this was only
Yeah, that's not. Is the gravitational force constant? No.
trying to swing the boat around in circles.
Oh, yeah.
It's not gonna happen. Right? That's why they have to do the same. If you want to retake that quiz on projectile motion, that needs to happen this week, okay? Which leaves basically today or tomorrow. Not Thanksgiving, not as you leave for Christmas break, okay? This week.
I'll come in for a week.
Yeah. Okay. Okay, first off, when you ever say anything about.
My mom was watching
velocity,
Cash
why
Cab
ask
and
anything
a
about
contestant named
velocity?
Kendall.
Questions on number two.
I don't know. Apparently some game show where you get in a taxi and you try to make money.
No.
How'd you
But
get your
we talked about it, it's just irrelevant. But what I do ask, I said, which values are constant? You never mentioned. You never mentioned, so you put in something I didn't ask about. And you left out something I did ask about. Yes, that's
Emma,
important.
how'd you get your name?
She's a doctor.
Okay, sometimes math isn't important, so.
It is when F equals big G mass of Mercury, mass of the sun over distance squared.
But is no the correct?
We're talking about your sister. She's adorable.
You have a sister?
No, Yes, Noah's right.
We did? Are you gaslighting people? No, you're gaslighting.
Yes, we had the conversation about.
Is that the relationship you're in?
Well, I thought you had a brother.
That's true, but the whole point of this is this word explains
She's not that
why
bad.
they are the same.
Like what you said about them, like taking a break together.
Kind of. Kind of. This is how much centripetal force you need to make this, right? That force has to come from somewhere. So it's either a strain, friction.
Almost filled in. Are these values supposed to be almost exact?
Yes. That's the whole. Yep.
Yeah, centripetal force changes how radius changes. That's what I'm gonna
Is it okay that I did a 2 centimeter to 1 inch scale on the vectors?
No. It's just a 1-to-1 ratio. Just draw them 1, 2.3.
Mara, you're smart. Where'd you get on
See
5?
them well enough.
If you already did it that way, leave it, just
1.27
make a
times
note
10
that
to the
says this is what I did.
I did. I wrote down what each of them are.
Okay,
There you go.
that's cool. What?
Is that better? And it asks what's changing.
Okay.
What is constant? With all this stuff, what's the constant mass?
Mass and gravity. Not like universal gravity.
Like gravitational acceleration.
Not little gravity.
No, she's talking about number 2.
Don't you think
I
that's
just erased it.
something to address?
Not
I had that earlier.
That's because you didn't talk, because you talked about philosophy, which I didn't like. What am I gonna talk about
Yeah, I heard him telling someone that's not supposed to be.
But that's like a third time I've heard it.
No, I just heard him say that. That is what it's supposed to be.
I swear. I've heard it from Alex to the office. You've been to
Did he not go the first time? I don't know. I have to go to the office typically until someone tells me because I never listen to what it says. And someone's like, didn't they just tell you to go to the office? And I'm like, oh, they did? And then I go. No. I only got called one time.